So today we are going to continue setting up our mind for reliability or for reliability centered maintenance. And today we are going to speak about proactivity, because proactivity is one of the, as they say, mouth-watering words or discussions that we are proactive in maintenance and we are doing things proactively and that such talks, but actually proactivity need to be rationalized using their reliability centered maintenance analysis to make sure that we are doing the right jobs, not we are doing some jobs to show off. What do we mean by this? We will see this in this chat. Simply, that's a bus-stop curve or one of the failure pattern curves where there's usually the premature due to repair or installations, that's a premature curves, and then we have the stable lifelong operations, and then near the end for some of the equipment there's some near the aging or the lifetime. It's 11% or 20, maximum 20% of the equipment faces aging, so it's we have the probability of failure increases. Actually, most of the equipment runs smoothly after it is safe from or it goes after the initial installation or repair or something like that, and it's stable after that. It goes running for, especially for the electrical equipment and many other equipment. But unfortunately, we need to take some action. We are used to take some action. That's where the reliability mindset comes. You don't need to take an action to make sure that your equipment is stable. You need only to take the needful action to make sure that your equipment is running stable. What do we mean by this? Usually, when we speak about maintenance and maintenance management and if maintenance is performing good, our maintenance program is very good or something like that. Sometimes we have the maintenance business unit, the results of the maintenance as a business unit is not that good. Maybe we are measuring it against many things. We are measuring it against the cost, which is a very primitive measurement. We are measuring it against the effect on the operations, and even we are measuring it against the alignment with the company objectives or the company goals, which is now measured using the ISO 9000, its latest versions. So we measure maintenance against all of this. Maybe adding some proactive activities can help us in improving the score, but it may not improve the actual results of the maintenance. Because sometimes proactivity is a trap on the long run. Why it is trap on the long run? So, because we need to understand what do proactivity mean. Proactivity means, if we take it as a literal from the dictionary, it means that we are taking an action based on anticipated future problem or future need or future change. So something is going to happen in the future, and I'm taking an action now to prevent this thing that I don't want it to happen. I prevent it now. That's typical for the maintenance we are doing. So we are doing maintenance, we are replacing, refurbishing, changing oil, making cleaning, making retightening, and whatever we are doing for the maintenance, that's to prevent a future failure. So that's a proactive action. We are doing this. So whatever action we are doing in the maintenance, for example, before the failure itself, or before induced failure, or before negatively affecting other equipment, or before risking the environment or the safety or whatever, when we are taking the action in advance, that's a proactive action. But the proactive actions are on two folds. Some of the proactive actions are taken based on the time base. So it's time-based proactive maintenance action, or it is operations-based maintenance actions. All these are proactive because you are going to do an action before the failure of the equipment. Also, the condition-based actions are proactive action, but that's another level. So when we say that proactivity is good for maintenance, yes, it is. Every proactive action you take to prevent the failure of the equipment is good for the operations, good for the maintenance, and good for the stability of the plant and so on. But does it work to take all these actions? That's where we can realize the importance of the reliability, because the reliability tells you that this action in maintenance is cost worthy. It's worth the cost you pay in this maintenance, or it does not worth. For example, let me take a practical example. I have this part that is recommended to change. It's a limit switch, it's a proximity switch, whatever. It's and some pairing. There's a recommendation to change some filter. A recommendation to change it every 3 months. But before the 3 months, after 2 months, it it was clogged and the pressure increased, and we need to stop and change the filter. So we reduced the maintenance time to 2 months. So now I'm changing the filter every 2 months, or changing this element every 2 months. So what happens if one of the machines had a failure within 1 month? So I will change the cycle again to be proactive, to take action before the failure. So I will change it to be 1 month, and so on. Chasing the failure is not the right thing. It's the analysis of why this failure happened, because this failure may be induced from something else. There are some rusting in the pipe, so the filter is clogged. There are some impurities coming with the oil, or while filling the oil or whatever, or some open points in the oil or in the grease, and the filters are clogged. And based on the clogging of the filters, I take action to change it early without treating the main reason. So frequent change of the filter is increasing the cost of the maintenance. So if I'm measuring only that I need no failure, so be proactive and go over the proactivity, whatever level of proactivity you like to reach. But if you are, it's important for you really the cost and the man hours and the available man hours and so on. You can considering this way while you are planning your maintenance or making your maintenance program, then you will not fall in the proactivity or over proactivity trap. That's one of the things that the reliability centered maintenance or the reliability analysis come to solve, that you don't make over actions. So for example, some of the oils, the oil in the hydraulic circuits, or even the oil in the transformers and so on, it's recommended to take a sample and test it every 6 months or every 1 year. So every 1 year I take samples and analyze it. So I found after 1 year that the condition is bad. So instead of solving the problem and then trying to find out why this problem came, because it's recommended for 1 year and expected that when I take a measurement and it's healthy, so I increase the life more than 1 year. So I will take now the sample every 6 months. So that's not the case. We need to find out why the condition is deteriorating after 6 months. It should be taken 1 year. So it's 1 year and more. So it's not 1 year and less, and I keep on decreasing my cycle. So that's the trap of proactivity. You can use the tool, whatever tools you like to be proactive. Maybe you can go with the sophistication of the proactivity. You can go sky high. Vibration analysis, you can go with thermal measuring and analysis. You can go with ultrasonic measurement and analysis. There are even now some imaging tools and so on to predict where is the failure can come from, or something like that, which takes an enormous number of shots to see the very little movements of the parts relative to each other. But you need the experts. You need the one who is having the experience in this. And these guys who are having this experience are very costly. So we need actually to see that can we invest? Maybe I purchase the equipment, but I don't have the experienced guy. So like this, I'm proactive. No, I'm just trapped in the proactivity. I'm getting the tool, but I don't have the right experience. Then I need to invest in training the people. And if someone leaves the company or retired, I need to invest in other people and so on. Do I need to make this, or it is not recommended to make this? That's all can be done only with the analysis. So we need to make sure that we are not just trapped in being proactive, we need to make sure that we are doing the right task that pays off. Okay, so from Jean Mauperé, the RCM2, he defines proactive task is worth doing if it reduces the consequence of the associated failure to an extent that justifies the direct and indirect cost of doing the task. So the cost have a direct cost of stopping the equipment, of using the tools, of the man hours invested, of the parts that's going to be changed and whatever. And having also indirect costs of opening and closing that may cause some other failures, or stopping and starting the plant, or increasing the fuel consumptions due to cooling and heating if you have this process, or using some chemicals or whatever. Whatever indirect costs are coming beside the direct cost of doing, which is in the time and the tool itself. So this mix need to be measured, and then it should be compared to the cost of the failure itself. If it is higher than the cost of the failure, so don't do it. Don't be proactive in this field. Okay, so it needs an analysis, it needs a study, it needs some time from you to make sure that you need to do this task, not just to be more proactive, no, to do this task because it is needed to be done. Okay, see you in coming chats with more insights from maintenance and from reliability centered maintenance, and we're going to see how to use the tools of the reliability centered maintenance in the coming chats.